here I have two pieces of paper lined up, and I've taken a straight edge, and what I've done is drawn a straight line here so that when I cut across this line, I'm going to get two triangles. Now, you should actually do this exercise if you didn't do it in class, or if you did it in class and didn't completely understand it, you should do it again. And this is an exercise that everybody in their life should do at the appropriate stage. First time probably at age about 7. Okay. So now I have two identical triangles. Now I don't want to have right triangles because our result is more general than it would be for just right triangles. So I'm going to cut the thing about here. Now it's clear that I don't have right triangles. Now the cut didn't come out perfect. Pieces of paper were shifting a little. Would have been better to do it with a straight edge and a sharp blade. But now I can take these two triangles and put them together to form a parallelogram. So I'm going to ask you to do that. You should do that. You should pause the video and actually form your parallelogram. Now I'm going to assume you've done so. Last chance to pause before you see me do it. Okay, well, take the two triangles, okay, have them the same orientation here, same distance apart, and I take one of them and flip it over and match up the two sides here, and now I have a parallelogram. So we see that any triangle you have can be copied and the second copy formed into a parallelogram. So what we have here is a triangle and another triangle upside down on top of it, forming a parallelogram. Now we haven't really proven that this is a parallelogram, and I'm not going to go into that detail now, but it's easy to prove that this side is going to be parallel to this side parallel to this side. It comes down to the simple fact that this angle here is equal to this angle here. Okay. Now, we've formed the triangle into a parallelogram, and as we've seen, we can form a parallelogram into a rectangle. So the next thing I ask people to do is take their parallelogram and make the line on which I should cut this parallelogram so that I can reform it into a rectangle. Now that's something we saw in the previous class, and everybody understood. I note that in today's class, nobody seemed to understand it because we've complicated the situation a little bit, and it doesn't look as simple as it did, although it is. And also because people didn't really, I noticed most people weren't taking notes, they just watched it done. Okay, yeah, I could do that. Well, take notes, you write it down, and you reinforce it, and then you're more likely to remember it later. Okay, so you should pause, take your two triangles, and draw the line that you would use, and then if that works, actually cut the thing out and form the rectangle. Okay, here's a line. I go from the vertex at a perpendicular to the opposite side, and I get a triangle here that could then be moved over here to form the rectangle. Now, here's the construction. Here's a picture of what that might look like. Cut the triangle with an altitude, or cut the parallelogram with an altitude from one of the vertices, and then take this and move it over here, and now I've got a rectangle. The base of the triangle, if we take the original triangle and let the base be B and the altitude be H, the base of the original triangle is going to be equal to the, well, here we have the base. We've got the piece we cut off and pasted back here, so that the distance from here to here, okay, from here to here is equal to the base. The altitude, which goes perpendicular to the base, is going to be the same as the altitude of this rectangle. So if I sketch the rectangle, I see that I've got B here, I've got H here, so the area of the rectangle is B times H. Now up here I've indicated the same altitude in the trapezoid, so that, or on the triangle, so that the area of the triangle is going to be related to the area of the rectangle. The rectangle is constructed of two triangles, so the area of the triangle is going to be half the area of the parallelogram, which is then half the area of this rectangle, which is 1/2 base times height. So the area of the parallelogram is the base times the height. The area of the rectangle is the base times the height being the altitude. And this is why the area of a triangle is 1/2 BH. Now, I commented that in the curriculum that we have in this country, that especially, I can be specific about in this area in Virginia, the curriculum's driven by the SOL. And the SOL never asks anybody to construct anything as far as I know, even though the stated standards are quite excellent. The test doesn't really uphold them all that well. And there are reasons for that. It's really expensive to do a test that would uphold these things, and we haven't spent the money on it. It's a lot of money. You got to prioritize your budget. Still, people are given this formula and tricks rather than insights into how to get right answers on an SOL test. And they never see this, okay? And this is important. It's important to understand these connections. In the first place, you can forget a formula, but you're less likely to forget a construction if you really understand it. Okay, well, anyhow, here is the formula for the area of the triangle and the reason for it.